We now have the legs, the feet, and the eyes figured out. But what about the body? Or head, or whatever it is? Well, in the case of Mr. Squeegee Feet, his body head thing is really just a big ball, and it really only needs one bone. We want to make sure to orient that bone well so that the local space for it makes sense for the animator, but other than that, there's not much to do. So let's just move right along to putting it all together. First, let's add an armature and put it into X-ray and wireframe display, and turn on axis visualization. Let's make this first bone the body bone. Move the bone a bit below the center of the body sphere, so it will rotate a bit more like hips during a walk. And align it so that the z-axis is pointing up. This way, the up-down translation axis will be the z-axis, just like everything else. Name the bone Body. And now let's add the thigh bones for each leg. Name them thigh.l and thigh.r. Now this L and R naming convention for left and right versions of the same bone is not just for clarity, although it is for that too. But if we name our bones this way, we can take advantage of a cool feature in Blender that automatically keeps bones mirrored across the x-axis of the armature. In the T panel, the panel on the left of the 3D view, there's a checkbox that appears when we're in armature edit mode, labeled x-axis mirror. Turn it on. Now, if we move one of the leg bones, the other stays the exact mirror of it. And this is going to help us set up the armature a lot more quickly, because we only have to do the edit mode positioning for one side. The other side is done automatically for us. Now position the thigh bones to align properly with the model. Select the tip of the thigh bone and extrude to create the shin. You'll notice that even the extrude happens on both sides. Convenient, eh? Now position the shins properly and extrude out the foot bone. Now unparent the foot from the shin, since the foot needs to be free, and make sure to select clear parent rather than disconnect bone. Disconnect bone would only disconnect the bones, but they would still have their parent-child relationship. Now duplicate the foot bone to create a toe bone, and place it appropriately. And make the toe the child of the foot. Notice that even parenting is properly mirrored for us. That's pretty cool. Now make the thigh bones the children of the body. And let's duplicate the toe to create the pole target. It's convenient since it's already the child of the foot. Now let's go name all of these bones. Unfortunately, naming is not automatically mirrored, since the mirroring itself is based on the naming, not the other way around. And that's it for the edit mode setup for the legs and feet. Now let's do the pose mode setup. Unfortunately, pose mode doesn't have any mirroring functionality, so we'll have to do everything on both sides. First, add the IK constraints for the legs. Now go and configure them. Set the chain length to 2. And set the pole targets. And adjust the pole target offset. Now lock the IK axes on the shins. And finally, configure the toes with Euler and the appropriate locked axes. Ta-da! That seemed pretty easy, eh? It was really just my long-winded explanations that made it seem complex. Now on to the eyes. Add a new bone for the eye target and position it. Now add 2 bones for the eyes and name them eye.L and eye.R. Position them appropriately. Duplicate them to create the parents, and make the parents a tad smaller. Make the eye bones the children of the parent bones, and parent the parents to the head. Now we're going to turn off x-axis mirror for a moment, because we don't want mirrored duplicates in the next step. Duplicate one of the parents and move it to the middle for the mind's eye. Now name all of these bones that we haven't named already. And go into pose mode and add the damped track and copy rotation constraints. And finally, lock the translation axes on the eye bones. Now we have a largely functional rig, but the mesh still isn't attached. So let's parent all the meshes to the appropriate bones. And let's apply the pre-made bone shapes to the control bones. And we should have done this next bit as we went along, but now let's go and identify the bones that the user never needs to touch and prepend MCH to their names and move them to another layer, because these are our mechanism bones. Strangely, the leg bones themselves are never directly manipulated by the user, so they actually are just mechanism bones. And the eye parents and the mind's eye are also never directly used by the animator. Now we're almost done, but we still have 2 more things to do that we didn't have to do for the bouncy ball rig. The first is that we need to create a root bone. What is a root bone? A root bone is a big-ass control that moves the entire rig with it. It's a pretty simple concept, and every character rig should have one. It's useful for a number of things, not the least of which is creating offsets for animation cycles. Fortunately, creating a root bone is pretty simple, as long as the various parts of your rig are designed in a way that doesn't sabotage it, and fortunately, ours aren't. So just add a bone at the base of the character and name it root. Align it so that its z-axis is up, because remember, we want the z-axis to be the up and down translation axis. And finally, simply parent any bone that doesn't already have a parent to it. In this case, that's the feet, the eye target, and the body. Notice that you can parent more than one child at a time to the same parent. Just select as many child bones as you want, and select the parent last. Now if we go into pose mode, you can see that everything moves with the root bone. I've also made a custom shape for the root bone, so let's use it. The final step is to sort the controls into different armature layers. When a rig gets complex enough, often the animator doesn't need to use all the controls at the same time, and having them all visible at once can be confusing. Sorting the controls into sensible categories and putting each category into different layers can make rig control visibility a lot easier for an animator to manage. In this case, our rig is still pretty simple, but I think it makes sense to move the secondary eye controls to another layer, since most of the time the animator won't need them, and they obscure the appearance of the eyes a bit. So let's move them to the second layer. Other than that, just turn off X-ray and axis visualization for the armature, and name the armature rig, and we're good to go. Woohoo!